Hello guys. So today I have decided to do this DSA problem, data structures and algorithms problem, where see, I didn't know about this problem, and recently I gave an interview and they asked me this problem. So problem statement was like this: given two sorted lists A and B, write a function that returns a single sorted list that contains all elements from A and B. You cannot use any libraries or sort method. Okay, and I watched few videos about this, and yeah, they have done a all. I mean, there are videos I watched and they are very good, but most of them have solved this problem by creating a linked list in Python. Okay, uh, I found that that is unnecessary for solving this problem, because I don't need a linked list, because I create a linked list out of Python lists only. I use to create those linked list methods using various list methods only. So why should I go and create that linked list? Okay, so I think there is I mean, using only those methods I can solve this problem using Python only. And not just this problem, but suppose you were given more than two lists, I can use this same algorithm which I am going to explain to you, and we can solve any number of lists here. Okay, so these two are the sorted lists. So let me first show you the expected output, what the problem statement is asking you to do. So it is saying that these are two sorted lists, right? 1 2 3 4, so it is in ascending order. So basically whenever we sort a list, it by default it gives us an ascending order, and 3 4 5 12. Okay, so these are two sorted lists. So if I merge these two lists, okay, I have to merge it in such a way that all the elements are there in the expected output list, but they are also sorted. So suppose so what is the algorithm that we use? What we do is we compare first elements from both the lists. Okay, I mean both of these. So I will choose the smallest one and I just put it here. Okay, one like this. Okay, and either see, now this element is taken. Okay, so my pointer for the first list will move to this one, and my pointer at second list will remain here because this element is still not handled. Okay, this particular element from second list. So here the pointer will move to here after I put one here, and on second list the pointer will stay here, and then I will compare these two. Okay, so smallest among these two is 2. Okay, so I will move this 2, I will put 2 here, and then because this is handled in my first list, my pointer in first list will move to this. Okay, and in second list pointer is still here. Okay, so there are two pointers basically, and in first list the pointer has moved to 3, and in second list this is still here. Now these two are equal. Okay, they both of these are equal. So I have to include all the elements. So I can do it like this. I can enter both of these elements here. Okay, and obviously my pointer will then move from here to here, and from here to here. Okay, so my first list pointer will be here and second list pointer will be here. Again both of these two are equal, so obviously I will do the same thing which I did for 3. I will put these values here. Okay, and my pointer is exhausted here. I mean, there is no it has 4 elements, so it is the third index. I cannot access the fourth index because it is not there in the first list. So I have covered all these elements. These two are remaining. So because there is no element in first list, I have nothing to compare with, right? So I can simply append these two at the end, and that will give me the sorted list. Okay, merged sorted list. And same way we can suppose there is another list C here, and same way I can create 3 pointers, and then I will compare the all the values at those pointers, and I will move on my pointers in respective list whenever the element is included here. So that is the procedure. So first let me create a function for these two lists, sorted merged list. I can call this sorted list merge function, suppose. Okay, so this is my function, and what it will take, it will take three lists input: list 1, list 2, and list 3. So these are the three lists that I will pass as an input. Okay, so and I have to see, I have to okay, first I will handle 2 only. Okay, so I have to create pointers for these two lists. Okay, so I can say pointer 1, it is suppose 0. Initially both of these pointers, I can create another one, will be set to 0. Okay, these are 2 pointers. Initial value will be 0 because I have to start from the left. Okay, so I will first compare the first element in both the lists. So initially they both are 0, and now what would be the maximum value of these 2 pointers? So I can say max point 1, max pointer 1. What is the value of the maximum of pointer 1 which it can have? It can have only whatever is the length of this list minus 1, because index starts from 0. So its value can be cannot be more than the length of the list 1 minus 1. This is the maximum value for pointer 1. Okay, and similarly max of pointer 2, it can not be greater than this. Okay, I am writing this code only to explain to you. I will not use these 2 pointers. Okay, because suppose there are n number of lists, I have to manually create these pointers then for n lists, right? So I don't want to do this. So instead of using this these 2 variables, I will simply use this dynamic value out of it and compare it later. I will explain where I will compare it, but for now let me just keep it like this so that you understand what I'm trying to say. So now what I will do that because initial values of this pointer is 0. Now I will say while pointer 1 is less than or equal to this max pointer 1, and pointer 2 is less than or equal to my max pointer 2. So what I'm trying to do here is that I will use another now if statement. If this is my pointer 1, right? So if list 1 pointer 1, if this will give me the value at that particular index, initially it is set to 0, so it will give this 1. Okay, this is suppose I am passing list 1 as list 1. Okay, so this will give me the value of 0. If this value is less than or equal to, I will say less than only, not equal to. If it is less than the value in second list at point wherever this pointer 2 is. Okay, if this is less than, then what I will do is I will create a variable here, sorted list. Okay, initially it would be empty. Okay, so this would be my output list that I will return from this function. So I will append this value, this one, okay, because this is the smaller one. Okay, so when I am comparing 1 and 3, this will give me 1 and this will give me 3, and 1 is smaller than 3, so sorted list will have the smallest element first, right? So I have to append it in this list. Okay, and at the same time, when I'm appending this, and now this value is taken, okay, so I should move my pointer 1 to next index. Okay, which index? So from 1 to 2, yani, that means 0 to 1. Okay, so this should move my index to next. Elif, I will use my elif statement, so that if this runs, this should not run, and if this doesn't run, I mean if this statement is not true, this, if this list one this value at particular index, if this is not less than index value in the list 2, then this will run. Okay, so that is the way. Don't use if here. Okay, that would not be efficient. I mean that is not optimized solution. So I should run only if it is necessary. So if this statement isn't true, only then I will check that if this is instead of this, what can happen is that these two values can be equal, right? It could happen that both of these values could be equal. In that case, I will append both of these values. Okay, I will, because both are equal, so I can simply append it like this. Okay, append 1 and append 2 values, or I can use like extend here, extend. Okay, extend, and then I will pass the list, and within that list I will pass the same value twice, so that would reduce my code to single line. So I am appending a list here. Okay, so extending my list. What is happening here? This is okay. Why is it still giving me error? Okay, was not closed, but it is closed, right? And list 2. Oh, this one is not closed. Okay, so both of these values are appended, so I will move both of these pointers by 1. Okay, so both of these index should move further. So I will give you an example. Suppose my pointer 1 is at 3, I mean it is at 0 1 2, and pointer 2 is at 0. So both of these values are equal, right? So I will simply put both values 3 in sorted list, and this index will move to this value, and pointer 2 will move to this index. Okay, so pointer 1 is moving to 3 index, and pointer 2 will move to from 0 to 1. So both are to be incremented by 1. And there can be a third case, elif. Again I will, or I can simply use else. Okay, because if these two are not the cases, then obviously the case would be that this one is greater. Okay, so if this is bigger, I mean first element is bigger, then I have to, in my sorted list, what I will do is I will, oh sorry, I'm putting it here only, I shouldn't put it here. And if, oh sorry, I should put it here, but not like this. Oh, actually I don't have to check this statement, right? So this would be the only case, so I don't have to, oh, sorry about this. So that's why I had put this column here initially. So the case would be that, and it would be greater. So in that case, I will copy this code from here. What I will append? I will append element from list 2, and pointer would be 2 only. Okay. Alright, so I have to use second point for second list, and I will increment my pointer 2 by 1. Okay, so this is the way we handle the merging of two lists. Now there can be a case where I don't have to use all this while loop and anything. Okay, so in that case, suppose if before doing all this, it could be that suppose my list 1 is like this. Suppose my list 1 is only up to this point 1 2, and second list is 3 4 5 12. Okay, so it is it is clearly showing that I can simply concatenate these two lists and it will still be a sorted list. Suppose I concatenate it like this, my output would be A plus B. Okay, so it will simply append here 3 here. Okay, and they are still sorted. Okay, and there could be another case where this is actually B and this is A. Okay, so in any case, whichever case, I have to check that if this condition is there, I don't have to check all the values at indexes, etc. I can simply concatenate them. So why to unnecessary process all this code? Okay, so for checking this, what I can do is I can check that if but this thing, this particular case would be valid only for two lists. If there are n number of lists, I would say that I have to process it with some for loop, etc. Okay, it wouldn't be that easier, I think, for analysts, because first I have to find out that what is the number of lists, and then for each list I have to see if that list is smaller than that element is smaller than particular list's first element, and if it is, even if it is smaller than the element, let me explain it by doing this like this. If list 1 if list 1's last value, if it is smaller or equal to value of first element in list 2, in that case I will return what I will return. I will simply concatenate these two like this. Okay, if list 2 so last element is less than or equal to first element in list 1, in that case I will return list 2 plus list 1. See, I used here list 1 plus this should not be here. I returned here list 1 plus list 2. Here I will return list 2 plus list 1. So be careful with this. Okay, so that would be easier to do it in case of two lists. But if there are a number of lists, then I have to check. That would be a totally different algorithm. So let us not discuss that as of now. So let us now so again, now this one here. So suppose now my list, because my list 1 has only suppose here, one second, so list 1 has 4 elements, it also has 4 elements, but after comparing these two values 4 and 4, my list 1's pointer will get exhausted. There is no other way forward for it to move, so all these elements will get consumed when this pointer is exhausted here. But these two elements are still remaining in list 2, which I would not have appended using this sort list extend or append function. Okay, so I have to include these remaining elements here. Okay, and it could happen in either case. Suppose there was a value of 15 and 18. In that case, these four and these four would get consumed, but these two would not still would still be remaining in, they would not be get appended with this code. Okay, so in either case, now after running this while loop, and one more thing, no, nothing. Okay, so sorted list dot append, but append what? Or I would say, sorry, extend. I have to extend a list whichever is not consumed, but which one? So let us see. I will extend list 1 and my pointer would be 2. Okay, I have to do it like this. Okay, not pointer 2 but pointer 2 plus 1, right? Because suppose my list 2 is consumed. Okay, yeah, so if my list 2 is consumed, in that case, so how would I know that my list 2 is consumed? I would know that if the value of pointer 2 and pointer 1 and pointer 2 I have initiated here, right? Yeah, so if my pointer 2 is equal to length of list 2 minus 1, if this has reached this value, maximum value, else I can say none. Okay, if this I am using this, I would say one line statement here. You can use an if else statement, but yeah, same way I can do it like this: append list 2, but here I would use pointer 1 to whatever is the end of the list 2. If suppose my pointer 1 got consumed, but this didn't. Which one? This pointer 1 got consumed but pointer 2 did not. So in that case this would run. Okay, so this will append the remaining elements from list 2, and this would extend this sorted list with the elements whichever we did not consume from list 1. Okay, so let us now print my sorted list here, but before that obviously I have to pass the run sorry, what is happening here? I have to run this function. What is the name of the function we gave? It is sorted merged list function. Okay, okay, so I am inside my function. I have to first remove the indent, so that so I would say sorted list is equal to sorted merged list function, and I will pass my lists, but I would not pass the original lists. Yeah, I can pass. I mean, I'm not mutating them, right? I'm not mutating these two lists, list 1 and list 2. So I can pass the original lists here. But just to be cautious, we can create a copy of both these two lists, so that I don't mutate these values within these two lists by mistake. Okay, within this function, so just to be sure. So once I did this, this will return me oh, I have to return here. I did not return sorted list. So this will return me the sorted list from here, and this value would get stored here, and then I am printing this. Okay, so this is my function, and let us run it now. So it was up to 4 only, and this is the expected output. Let us see if we get the same output or not. Okay, so there is an error, and the error is at line 18. Line 18. Oh, index is list 2 minus 1 index is what is the error? If this is this value is less than or equal to this. Okay, and this list 1. Okay, what is saying? Not supported between instances of int and type generic alias. Okay, so this is the naming problem. Actually, I did not put 1 here. So if I run this again, we should not get the error. Okay, so the sorted list we got out is up till 1 2 3 3 4 4. Okay, what did happen here? So it is what did happen here is actually we are missing these two values. Okay, so I think this thing did not. Oh, okay, so this should be no, 1 second. I am using slicing here, but I did not. Let me check this. I think this what this do is I am not storing these values. I think that's what is happening. So I can maybe list 1 pointer. Okay, so I think there is something going on here. I can first let me try the if block here. If point, let me try like this. If pointer 2 is equal to length of list 2, in that case I would run this. Sorry, let me run this, and I don't need else here, but I can use elif here. Okay, and in my elif I can put this statement from here to here, and I will run this list comprehension as well, but first let me just do it in a simple way. So, and we are having, yeah, so now this should run. Okay, and what I will extend here is sorted list 1. Yeah, so I will be extending because pointer 2 got exhausted, so elements would be remaining in list 1, right? So I can put it like this, from this to end. Okay, and I don't have to use the last element here. I mean, I can put it like this. Okay, so let us check it quickly now. Okay, it still is not running. So 1 second. In this case B would not be consumed, right? So B would not be consumed, and length of list 1 actually. So okay, so this is the problem. See, this is the problem. I did not put list 1 here. No, this is not the problem. Or did I not save it? Okay, so let me check if this is running or not. I can check it by running like this. Okay, so let us check if this code is running. Okay, so it is not running. Okay, before that let me print the values of pointer 1 and pointer 2. So let us debug this. Okay, let us run these two. Let us find out this value. So pointer 1 is at 4 and pointer 2 is at 2. Okay, so we can see that 0 1 2. So this is my pointer, right? Yeah, this is my pointer, and yeah, this is my pointer. So my pointer 2 is see, my pointer 1 got consumed, right? So this is the length of the list 1. So length of the list 1 is 1 2 3 4, and my pointer is at okay, so it got incremented actually. So I should not put it -1 here. So that is then the logic problem. I did not use the correct logic. So now if I compare it with the length of the list 1, length of the list 1 is 4 and pointer 1 is at 4. Okay, so this will then return true and this will run. Okay, and now what would happen, because elements are remaining in list 2, so wherever oh, and I don't have to use the pointer 1 here. I have to use pointer 2 here. From pointer wherever is the pointer 2 to end, pointer 2 is at 2, so from pointer 2 in list 2 to what end of the list, and same here. So this is a problem. I hope you already have figured it out. So now let us run this. Yeah, so now it is giving me the merged list here. So that is for the two lists, right? So suppose there are n lists, there can be now n lists here. Okay, so if there are n lists, in that case what I can do, okay, so that would be a case for a recursion. Okay, we can keep running this while loop, but yeah, I think I should first prepare that code by myself. Okay, actually I have to create another video for this. So if you need that, please say, and I will create that code as well. Okay, so that's all for this video. And sorry guys, if you're hoping that I would create the code for all the number of lists, because I think the video would become lengthy and I have to think about it. Okay, I thought it would be easy, but after thinking more about it, I think that would be a bit complex. Okay, so yeah, that's all for now. Thank you, and do subscribe if you haven't yet, and we can keep learning together in future as well. So let me now stop here. Thank you, take care, and bye bye.